This question comes from Noah, who asks, what if the Earth were made entirely of protons and the Moon were made entirely of electrons? This is, by far, the most destructive what-if scenario to date. You might imagine an electron moon orbiting a proton Earth, sort of like a gigantic hydrogen atom. On one level it sort of makes sense. Electrons orbit protons and moons orbit planets. However, electron moons do not orbit proton planets. If you put two negatively charged electrons together, they try to fly apart with a force about 20 orders of magnitude stronger than the gravity pulling them together. If you put 10 to the 53 electrons together to build a moon, they push each other apart with an unbelievable amount of energy. The Moon and Earth would have no chance to gravitationally or even electrostatically influence each other. The forces trying to blow each one apart would be far more powerful. If we ignore general relativity for a minute, we'll come back to it. We can calculate the energy from all these electrons all pushing on each other would be enough to accelerate all of them outward at nearly the speed of light. But this is one of those situations where saying nearly the speed of light isn't very meaningful. The electrons in a normal particle accelerator also go at nearly the speed of light, but the electrons in the exploding moon each have orders of magnitude more than the Planck energy, which is itself many orders of magnitude larger than the energies we can reach in our largest accelerators. In other words, Noah's question takes us pretty far outside normal physics into the highly theoretical realm of things like quantum gravity and string theory. So I contacted a string theorist and I explained Noah's scenario. Dr. Keeler agreed that we shouldn't rely on calculations to give that much energy to each electron, and she told me, I don't trust anything with energy per particle over the Planck scale. The most energy we've really observed is in cosmic rays, more than the LHC by circa 10 to the 6th, I think, but still not close to the Planck energy. Being a string theorist, I'm tempted to say something stringy would happen, but the truth is we just don't know. Luckily, that's not the end of the story. Remember how we're ignoring general relativity? Well, this is one of the very, very rare situations where bringing in general relativity makes a problem easier to solve. There is a huge amount of potential energy in the scenario, the energy that we imagined would blast all those electrons apart. That energy warps space and time just like mass does. The amount of energy in our electron moon, it turns out, is about equal to the total mass and energy of the entire observable universe. An entire observable universe where the mass energy concentrated into the space of our relatively small moon would warp space-time so strongly that it would easily overpower even the repulsion of those 10 to the 53 electrons. Dr. Keeler's diagnosis? Yep, black hole. Would the attraction of this universe as black hole cause the rest of the universe to collapse? It's hard to say. The answer kinda depends on what the deal with dark energy is, and nobody knows what the deal with dark energy is. But for the meantime, at least, nearby galaxies would be safe, since the gravitational influence of the black hole can only expand outward at the speed of light. Most of the universe around us would remain blissfully unaware of our ridiculous electron experiment, until they suddenly... Oh. Ding, 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 ding.